Now let's switch to annuities due. An annuity due just means that the first payment is due immediately at the beginning of the year instead of at the end of the year. So here's our first version of future value of an annuity due structure. And you can see that we have, again, 4 pieces of information. We have a payment, we have an interest rate, an N, and a future value. So here's our interest rate, here are our payments, here's our number of periods, and here's our future value. Again, each of the payments has to be the same, and they have to occur in consecutive periods. So note the difference in the structure. If this were a future value of an annuity, these payments would be shifted 1 period into the future. If you invest $100 at the beginning of each of the next 5 years, starting today, how much will it be worth at the end of 5 years at a rate of 8%? So here we have payments at the beginning, and we want to figure out what it will be worth at the end. Well, we could use our formula, and there's our formula for annuity, for future value of annuity factor here in the bracket. But since all the payments will receive interest for 1 additional year because they are put in 1 year earlier, we have to multiply by 1 plus I. That is, in this case, 1.08, in order to figure out what that future value would be. If we were to plug numbers in, let me see if I can't get this to stop refocusing all the time. If we were to use the formula and plug in the numbers, we get 633.59. Now, does that number make sense? Well, we've got $500 worth of payments and an 8% rate. Does that make sense that these $500 would grow to $633.59? Well, it seems like it's reasonable. And now here we'll use the calculator. So calculator on, clear TVM, clear work. And our payments are 100. So 100, change signs, is our payment. And 5 is our N. And 8 is our rate. Compute future value, and that comes up to be 586.66. So what went wrong? Well, we forgot to change it to beginning of period payments. So if there is nothing above here that says BGN, then the calculator is assuming end of period payments. We need to have beginning of period payments. So we're going to have to make that change, and here's how you do it. You hit the second key, and then this key that said the payment key, only now that you've hit second, it's not payment anymore. It's the writing above, the label above, which is BGN for begin. So we're going to click that, and it says end, but it's not really end. So now we're going to put second set, and you see it says BGN. Now I'm going to clear entry, and now you see up at the top it says BGN. That's for beginning of period payments. So now we have beginning of period payments. So let's see what comes up. We've got 100. Change. You know what? I'm going to clear the calculator. Second clear TVM. Second clear work. 100. Change signs is our payment. 5 is our N. 8 is our rate. And I need to compute my future value, 633.59. So we got the right answer. That seems pretty good. What you would normally do, what I would strongly encourage you to do, is immediately change back to end of period payments, because most problems are annuities, not annuities due. And to go back to end of period payments, you just do the same thing that you did to get to beginning of period payments. Second, begin, second, set, clear. And now the BGN has disappeared and your calculator is set for end of period payments. Let's look at another structure. Well, same structure, it's just what's the knowns and what's the unknown. So in this case, we know the future value, but we don't know what the payments are. So we know I and N and FV, the future value, but we don't know the payments. If you want to accumulate $10,000 in 6 years and want to make equal payments at the beginning of each of those years, how large must the payments be if the rate is 6%? So here we have our rate, here we have our number of years, here we have our future value, and we're trying to figure out what it would take to accumulate that $10,000. Well, as we did before, we could say 10,000 divided by 6 equals 1666.67. So would it take more or less to accumulate $10,000 than 1666.67 per year? Well, it would take less because we're going to earn interest. So going in, we can figure it's going to be less than 1666. So here's the formula. Again, same number in the brackets, but we've turned around this stuff, and so instead of multiplying, we divide. And again, since the payments are at the beginning of the period, we're going to have to adjust for the fact that there is 1 year of additional interest for each one of those payments. So if we plug the numbers in, we get $1,352.48. Now, does that number make sense? Well, it's less than 1667, so it seems to be in the ballpark. Let's go back to our calculator. We're going to clear everything. Second, clear TBM. Second, clear work. And now we have to remember, go back to beginning of period payments. So beginning of period payments, to do that, we say second, begin, second, set, and clear. And it says BGN up at the top. So now we're going to plug our numbers in. So let's go ahead and make sure everything's cleared out. Second, clear TBM. Second, clear work. So everything's done. And now we have 10,000 as our future value. 10,000 is our future value. Our number of periods is 6, 6N. Our rate is also 6, so 6 IY. And now we're going to compute the payment. We get $1,352.48, which is the same number that we got over here. So it looks like we're in good shape. Here's another version. In this case, we know the future value of the annuity, we know the payment, and the N. What we don't know is what's the rate. You plan to invest $1,000 at the beginning of each of the next 4 years. If you want to accumulate $6,000 by the end of the 4th year, what rate must you earn? So here's our structure. We know the 1,000s, we know the 6, and again, recall that your calculator requires that either these numbers all be negative or this number be negative, one or the other. Got our N, got our future value, got our payments. What's the rate? Well, we're not going to do the calculation stuff for the format and solution. We're just going to use the calculator. So again, at this point, I already have it as in begin, so I'm not going to have to make that switch. I'll just leave it as it is, but I urge you to change it back every time. So second, clear TVM, second, clear work, and hit clear once more. It says begin up at the top. And now let's plug our numbers in. 1,000 plus minus, that change sign key, is our payment. 4 is our N. 6,000 is our future value. Compute the rate, and we get 16.90%. So that looks like it worked out pretty well. Now let's look at the last structure. Future value is known, the payment is known, I is known, but we don't know N. Again, this is not one that we use very frequently, but here we go. Fran is starting a savings program. She will deposit $1,000 annually with the first payment made today. If she earns 10%, how long will it take to accumulate $7,000? So here's our setup. We have to accumulate $7,000. We don't know how long we'll be doing it, but we're going at 10%. Well, what do we know about our N? What does it have to be less than? Well, if it were 7 years, 1,000 per year for 7 years at 0 interest would get us 7,000. So we know it's going to be something less than 7 years because those payments all receive interest. So here we have the calculator version. I'm going to clear everything. Second, clear TVM. Second, clear work. We're already set for beginning of period payments. And I'll try to be clear and say beginning of the year, or we start payments today, or something like that. It won't be, there's no intent to confuse anybody on a test using either beginning or end of period payments. It should be very clear from the way the problem reads. So we're going to second clear TVM, second clear work, clear everything. And now we're going to go ahead and put in our data. We've got 1,000 plus minus is our payment, and 10 is our rate. 7,000 is our future value. It's opposite sign. And we're going to compute N. So compute N, and we get 5.17 years. Let me just show you for a second what happens if you do accidentally forget to change signs. And you've probably already seen this because you've probably made the mistake, because everybody does. If I put 1,000, it's the same problem, without changing the sign as my payment, and I put 10 as my rate, and I put 7,000 as my future value, and then if I try to compute N, oops, comes up with a negative number. So this indicates that it would take a negative 10.61 years for this to work out. Well, we normally don't figure negative time, so that's a problem. So we need to make sure that when we enter this data, we have one number as a positive and the other number is a negative. In this case, we make the 1,000 an outflow, and so we make that negative, and the 7,000 as an inflow. Now let's look at present value of an annuity due. So the structure is just like a present value of an annuity, except the payments are at the beginning of the period instead of the end of the period. Again, 4 pieces of information. In this first one, we know these 3, and we're going to solve for this one. A manufacturer offers you 6 payments of $800 per year for rights to your invention. Using a 7% discount rate with the first payment due immediately, how much cash would you accept right now in lieu of the annual payments? Well, let's think about this as we look at these $800 worth of payments. $800 and 1, 2, 3, 4, 5, 6. 6 times 800 is $4,800. So if they offered us $4,800 right now, we'd be happy to accept it. But they're not going to do that. They're going to offer us some amount less than $4,800. And how much less depends on what this discount rate is. Well, it's 7%. So let's show the formula. Well, here's the present value of an annuity formula here, and formula for a factor for present value of an annuity is this part in the brackets. And then it has to be adjusted to consider the fact that this is an annuity due, not an annuity. So this is the format. If we plug the numbers in, it would look like this. And we'd calculate $4,080.16. Well, let's go to the calculator. Second clear TVM, second clear work. We do have BGN up at the top. And let's plug in our numbers. 800 is our payment. is our payment, 800 payment. 6 is our N. 7 is our rate. Compute present value, 4,080.16. Now, notice that time I didn't put, I put what $800 as a positive rather than as a negative, and I came up with a number that was listed as a negative. Obviously, I know that 4,000 is a positive number that's coming in to me. Look at another version. In this case, it's the present value of an annuity due. We've got an interest rate and an N, and we're trying to calculate what the payments are. Now, this is a little bit awkward because in this case, we have a payment that occurs at the same time as this big cash flow. So this payment would not essentially not be discounted. Let's go with this, though. A prospect says she will buy your business for $100,000 but wants to pay in 5 equal annual installments. If the first installment is made today and you require a 12% return for financing the sale, what will the payments be? Well, note that there are 5 payments, and since if there were 5 payments at 0 interest, then they would be $20,000 each. But there is interest, so the payments need to be higher than $20,000. So we know that going in. Here's the formula. And again, we've switched from multiplication to division because we turned around this equation. And again, we have to adjust for 1 plus I. And when we calculate it, we come up with $24,768.73. Is that greater than the $20,000 that would have been the answer if there had been 0? Yes, it is greater. So is that right? Well, we know it's the right answer, but even if we weren't positive, we know it's in the right direction. If we use our calculator, we would put in 100,000 as our present value. 5 is our N. 5N. 12 as our rate. And compute the payment, $24,768.73. And again, that's a minus sign. We know it's a positive dollar amount, though. Look at the third version. We know the present value, we know the payment, we know the number of time periods, but we don't know the rate. Sally is offered $8,000 for her invention. As an alternative, she can receive 6 annual payments of $1,500 with the first payment made today. If she accepts the annual payments, what is the implied interest rate? Well, let's take a look. We've got 1, 2, 3, 4, 5, 6 payments, and 6 times 1,500 would be $9,000. So we've got to discount $9,000 worth of payments back to the present to equal $8,000. Well, that's not a huge rate because 9,000 is not that much bigger than 8,000, so we know the rate's not going to be huge. We're going to skip over these two, the format and the solution, and go straight to the keystrokes on our BA2+. Second, clear TVM. Second, clear work, and clear again. And we're going to put in 8,000 as our present value. 1,500, change signs, as our payment. 6 is our N, and we're going to compute the rate, 4.97%. Now, again, the last one, we're calculating N, and that's not the most popular type of calculation, but we'll do it anyway. Future value of an annuity due is known, the payment is known, the rate is known, and we're solving for N. Gary is offered $10,000 for his financial planning practice. Instead, he asks for $2,500 per year for the rest of his life with the first payment due today. How long would Gary have to live for the annual payments to equate to a 12% rate of return? Not sure I'm real comfortable with Gary's decision here, but we'll go with it. And note, how long does it take to get your $10,000 back if there were no interest rate? Well, 1, 2, 3, 4 years it would take to get your $10,000 back. So even at 0, it would be 4 years. But it will be discounted, so it has to be something greater than 4 years. Well, let's calculate. Second, clear TVM. Second, clear work, and then clear the entry. We're still set at beginning of period payments. So we've got 10,000 as our present value, 2,500 plus minus our payments, 12 is our rate, 12 rate, and now we're going to compute in. Compute in, 4.94 years. So there you have present and future value of an annuity and present value and future value of an annuity due in these last two sessions. And in the next session, we'll go to present value of uneven and grouped flows. As you see, we're at the end of the first handout, so we're going to go into the second handout, so have it handy so you can follow along.